Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 4.4 for course 2, 4th period, solving equations by multiplying or dividing. That in fact is our objective for the day. Okay, so in the previous section we dealt with addition and subtraction. Today we're going to be dealing with the inverse operations of multiplication and division. Okay. So, the division property of equality tells us that if you divide each side of an equation by the same non-zero number, the two sides remain equal. Okay, so here we're going to look at it with arithmetic, and let's see what happens. Since 3 times 2 is equal to 6, there's your equation, 3 times 2 divided by 2 should be the same, or is the same, as 6 divided by 2. Well, let's check this here. 3 times 2 is 6, divided by 2 is 3, 6 divided by 2 is 3. So again, we see that it is in fact telling us the truth here. That does work out. Not as easy to see with variables, but the idea is the same. If A is equal to B, then A divided by C is equal to B divided by C. However, there is a stipulation that C cannot be 0. And that's because division by 0 is undefined. Okay. So again, in this case, we're dividing each side by the same number, and if we want to do that, we should maintain equality. The multiplication property of equality tells us that if you multiply each side of an equation by the same number, the two sides remain equal. Okay, so let's look at something with some arithmetic in it. 12 divided by 2 equals 6. So if I want to multiply each side by 2, and this 2 here is random, it could be anything. 12 divided by 2 is 6, times 2 is 12. Here, when I put in 6 times 2, I get 12. Okay, so again, the idea is when each side is simplified, I'm going to remain with the same answer. Remember, or the same equality, or the equality is going to remain true. I'm sorry, I'm not getting my words out very well. Again, remember that's the goal here in what we're doing. We're trying to keep our sides balanced as if we were on a seesaw or a balance scale or something like that. So, algebraically speaking, if A equals B, then A times C equals B times C. Alright, so again, maybe a lot for you to absorb. If you need to pause and go back and read and think back through this for a minute, you can. At this point, though, I'm going to go on to solving equations by dividing, and I'm going to talk through this. As with the other section, we'll go over a lot of these in class, and I may even show you some alternative ways to do these then as well. Okay, so here we go. We want to solve negative 3j equals 44.7 and check your solution. So the first thing we want to start out is notice that j is being multiplied by 3. The inverse of multiplication by 3 is division by 3. Excuse me, negative 3 I should be saying. So what that tells me is, again, my goal is to make this 1j, or just j. And we need to divide each side by negative 3 to get j alone. Okay, so I'm going to write divide by negative 3. And I'm writing this, remember we've talked about many, many times how division can be written as a fraction. Okay, negative 3 divided by negative 3 is positive 1. So I'm just left with 1j, or just j. I don't write down to 1 usually if it's a coefficient of a variable. And then I need to figure out what 44.7 divided by negative 3 is. So I'm going to do it off to the side because it's easy math. We're dividing just by negative 3. I want to be sure that I remember that I'm going to get a negative quotient. 3 into 4 goes 1 time, negative 3. Okay. So that's going to give me a 3 here. 1, bring down the 4. 3 times 4 is 12. So that works. Then I have 2, bring down my 7. 3 into 27 goes 9 times. So my digits at the top are 1, 4, 9. They're negative. Don't forget that you do need to bring up your decimal point into your answer as well. So J equals negative 14.9. So we're going to check our solution with the original equation. So I'm going to find out if negative 3 times negative 14.9 gives me positive 44.7. So again, I'm going to replace the J with negative 14.9. And I'm just going to go off to the side here and multiply. Negative times negative means I'm going to have a positive result. 3 times 9 is 27, carry a 2. 3 times 4 is 12, plus 2 is 14, carry 1. 3 times 1 is 3, and 1 is 4. I'm going to count decimal places. I only have one digit behind the decimal in my problem. That will give me one digit behind my decimal in the answer. Negative times negative makes my answer positive. I'm sorry, you know what? And I wrote down the 2 over here instead of the 7. My apologies. 3 times 9 is 27. I should have written down a 2. A 7. I should have written down a 7. So I get 44.7, which checks with what I want it to do. So again, 3 times 9 is 27. Please write down the 7, carry the 2. Sometimes when I'm talking, I do write down something other than what I'm thinking, so my apologies. Okay, let us go on to another example. The art club must buy 84 pieces of poster board. There are 6 pieces of poster board in a package. How many packages of poster board must the art club buy? Okay, so they need 84 pieces of poster board, 6 pieces in a package. How many do they need? Okay, so 6 pieces times the number of packages is going to equal the number of pieces that they need to buy. Let P equal the number of packages to buy, so again defining our variable here. And we're going to take the number of pieces in the package, 6, times the number of packages that you need to purchase, should equal 84, the number of pieces the art club needs to buy. So my equation is 6 times P equals 84. Don't need the time sign in there, but it's there this time, okay? So what I'm going to do, I want the P to be isolated, so I want the 6 to go away, so I'm going to divide each side by 6. 6P divided by 6 is just P, or 1P. Some kids like to mark it out lightly like that so they remember they've done it. 84 divided by 6, not a times table, so let's go off to the side. 6 into 8 goes 1 time. You have 2 left over. Bring down the 4. 6 into 24 goes 4 times. So I get 14. So P equals 14. The art club must buy 14 packages of poster board. And we can check that by doing, it doesn't ask us to, but we can do that, into the original equation, 14 times 6. Okay, 6 times 4 is 24. 6 times 1 is 6, and 2 is 84. It should give me that if it's the correct answer, and it is. Okay, kind of ran into that problem a little bit. Okay, all right, now let's solve an equation by multiplication. So we want to solve m divided by negative 3 equals 27. So notice that, again, we have to notice that m is divided by negative 3. To undo division of negative 3, we need to multiply each side by negative 3. So I'm going to write negative 3. Some kids like to write negative 3 over 1, and I'll explain in just a moment why. And then I'm going to write my negative 3 over here as well. Remember, negative 3 and negative 3 over 1 are 2 different forms of the same number. So that's okay to do that. The reason that it's sometimes handy to do this because then you understand the cross-canceling that we've worked on before. Basically, I'm dividing by negative 3 and multiplying by negative 3. It allows me to cross-cancel them out. So I'm just left with m over 1, or just m. And negative 3 times 27 is negative 81. So my solution is negative 81. Again, it didn't ask to check, but let's look at the check here. I'm going to take negative 81 and divide by negative 3. My answer is going to be positive. So I have negative divided by negative. 3 into 8 goes 2 times, so that's 6. Bring down the 1. 3 into 21 goes 7 times, so 27, it checks. 27 equals 27. Okay. All right, so you have some quick checks here. Please have these done for the next time we meet in class. I look forward to seeing you soon.